Now that we've discussed the skin as the part of the integumentary system that is found on the outside of the body, it's time for us to transition into some different body membranes and epithelial membranes that are going to be found more towards the inside of the body. The epithelial membranes that we're going to discuss here are often referred to as simple organs. Thinking back to what an organ is made up of two or more types of tissues. So an epithelial membrane is a simple organ because it's made up of an epithelial sheet of tissue that rests upon a layer of connective tissue. So each of the epithelial membranes that we're going to discuss here are made up of two different layers of tissues. Overall, there's three different epithelial membranes that we need to be aware of. The first is the cutaneous membrane, the second are mucous membranes, and the third are serous membranes. Now I'm just going to go ahead and real quickly explain that the cutaneous membrane does in fact refer to the skin. Cutaneous means superficial, so this is of course the layer on the external part of the body. The only thing that I could really even ask about the cutaneous membrane is what it is, and it is the skin. So it's the mucous membranes and the serous membranes that are going to have a little bit more information behind them. These two types of membranes are in fact epithelial membranes, so they are simple organs and contain an epithelial layer with an underlying sheet of connective tissue. But it is the arrangement and secretory products that distinguishes mucous membranes from serous membranes. So first and foremost, as their names suggest, their secretory products are going to be just as they sound. Mucous membranes secrete mucus, and serous membranes secrete serous fluid. Serous fluid is a very lubricative fluid, and it helps for organs to glide past one another instead of scrape past one another. But the other major difference between mucous membranes and serous membranes are the arrangement and where we find them. Mucous membranes can only be found lining cavities that are open to the external environment. A few examples of these would be the respiratory system, the digestive system, as well as the urinary system. While all of those systems are found nestled deep within the body, they are still contacting the external environment through some type of opening. The respiratory system connects to the external environment through the mouth, the digestive system connects to the external environment through both the mouth and the anus, and then the urinary system is going to connect to the external environment through the urethra. So despite the fact that the respiratory and digestive cavities are found very, very deep within the body, they're still considered the external environment because they connect with components in the external environment. When we eat food, that's an external substance. We take that into our body through the mouth, and it is truly absorbed into the body through the digestive system. So any cavity that's open to the external environment will be lined with a mucous membrane that secretes mucus. Serous membranes are going to be lining closed cavities, and these are cavities that will in no way contact the external environment. We have three serous membranes that we're going to discuss: the peritoneum, the pleura, as well as the pericardium. So let's talk a little bit more about each of these three types of epithelial membranes. Of course, the cutaneous membrane is the skin. This is the part of the integumentary system that wraps around the outside of the body, and it is the most superficial body system of all 11. Next up are the mucous membranes, and we often refer to mucous membranes as the mucosa. Mucous membranes are going to be considered wet because they will be covered in either mucus or some other body fluid. For example, in the urinary system, it would be bathed in urine. But the respiratory system and the digestive system will both secrete mucus. As I just explained a minute ago, these mucous membranes will line body cavities that are open to the external environment in some way. Another location that we'll find mucosa is lining the inside of the uterus in females. We don't want to forget our roots in that mucous membranes are simply a layer of epithelial tissue that lies on top of a layer of connective tissue, also known as the lamina propria. And you can see the respiratory cavity as well as the digestive cavity depicted on this slide. Mucous membranes will be lining the cavities of these two systems because they contact the external environment. In these systems in particular, mucus is very important for capturing potential pathogens that make their way into the digestive or respiratory systems through the mouth. Now, our third type of membrane are the serous membranes, which can commonly be referred to as serosa. Much like the mucous membranes, this is still going to be two different layers of tissues, one layer of simple squamous epithelium, and another layer of underlying connective tissue. The serous membranes will release serous fluid, which is extremely important for lubricating organs inside of the body. If we consider how often our body moves around, It is crucial that we have a lubrication method to decrease friction inside of the body. We don't want our heart and lungs grinding past one another as we bend over and move. We want these organs to glide past one another so that when we move, we're not sustaining any lasting damage. Unlike the mucous membranes, serous membranes, or serosa, are going to line body cavities that are closed to the external environment. So if you think about that, there's no real opening to the cavity inside of a serous membrane. Serous membranes are sort of like very flat balloons that wrap around different organs and help to keep the friction inside of the body low. I personally always like to use this picture to demonstrate what a serous membrane is going to look like. So you can see a balloon shown right here with this fist that's been impressed into the balloon. So on the inside of the balloon, there's a cavity. There's a little space in here that's going to contain the serous fluid. But the balloon has been tied off, so there's no real opening for any air to get in or out. As you can see, the fist that's impressed into this balloon is going to give rise to a second layer, which is known as the visceral layer of that serous membrane. So there's actually two layers. There's a parietal layer, which can be found out here, and then we're going to have a visceral layer, which is found on the inside. Every serous membrane is going to have a parietal layer and a visceral layer. And between those two layers, we're going to have some type of space that contains the serous fluid. So out here, you can see that this is the parietal layer. Whether it's the peritoneum, the pericardium, or the pleura, this would be the parietal layer of it. And as we go further in, this layer that's going to be contacting the hand itself, that's going to be the visceral layer. So the visceral layer contacts the visceral organ, hence why we call it the visceral layer. The parietal layer is actually going to be pushed up against the wall of whatever cavity that serous membrane is found within. So despite having three different serous membranes, all serous membranes are going to be arranged in this way. Let's take a look first at the pericardium. The pericardium is named because it's the serous membrane that wraps around the heart. Peri means around, and cardium is referring to the heart. So you can see that this serous membrane is wrapping around the heart itself. You've got this outermost layer over here, which is the parietal pericardium. You have the pericardial space, and the serous fluid will be inside of that pericardial space. And then we're going to have the visceral pericardium, which actually contacts the viscera itself. The pericardium is probably the easiest one to visualize because it's only going to wrap around the heart. The heart is simply impressed in this serous membrane, just like the fist from the last slide was impressed in the balloon. So our three serous membranes that we have are going to be the pericardium, which surrounds the heart, and we've just seen this. And there's two other serous membranes known as the pleura, which are going to wrap around the lungs, and those are going to be found in the thoracic cavity. And then we have the peritoneum, which is going to wrap around many of the digestive organs and be found within the abdominal cavity. Now the pericardium, like I mentioned, is probably the easiest because it wraps only around the heart. The pleura are also fairly simple, but there's two of them. So you have to make sure that you understand that there's a right pleura and a left pleura, and those are going to wrap around the lungs. And the peritoneum is generally the most challenging to visualize because it wraps around so many different things. Once again here you can see the parietal and visceral pericardium, and on either side you'll see the parietal and visceral pleura. These are arranged exactly the same way as the pericardium is. There's just going to be two of them as they're wrapping around two different lungs. It's the peritoneum, I think, that gives students more of a problem. However, I will tell you that the peritoneum is just the same as the pericardium and the pleura. It's simply wrapping around more things. So, out here you'll have the parietal peritoneum, and then as more and more organs are impressed within this peritoneum, they're going to form other layers and different folds inside of here. So this is going to be the visceral peritoneum, which can be found on the inside. So we've got the parietal peritoneum on the outside, and then the visceral peritoneum, which is going to be found here, contacting the organs themselves. Because of the intricate arrangement of the peritoneum, there will be a few other structures that arise from this, such as the mesenteries and the omentum, but you'll discuss those two components in much more detail in anatomy and physiology too. We just want to get an idea that every serous membrane has a parietal layer, a visceral layer, and a space between the two. And despite how many things are impressed within them or how many we have, they all work the same way and carry out the same functions of decreasing friction inside of the body. So the final type of membrane that we are going to discuss is actually known as a connective tissue membrane, and that is the synovial membrane. The synovial membrane doesn't have any epithelial tissue, it's simply going to be made up of connective tissue. And this membrane is going to be found solely lining the inside of synovial joints, bursa, and tendon sheaths. As we can tell by the name, the synovial membrane is going to secrete synovial fluid, which, much like serous fluid, does act as a lubricant inside of the joints. Synovial joints are only one type of joint, but they do contain that synovial cavity so that they can contain synovial fluid and allow the structures of the joint to slide past one another. For those of you that aren't aware, bursa are just little sacs that contain synovial fluid, and tendon sheaths are just elongated bursa that wrap around tendons to cushion them and decrease agitation. You can see a synovial joint shown right here with the synovial membrane lined in green. Now, synovial membranes are discontinuous, which means that they do not actually line the entirety of the inside of the cavity. This here is going to be articular cartilage, which you'll learn a little bit more about in your next lab video. But you can see in green here the synovial membrane that's going to secrete synovial fluid into this synovial cavity. You can see this sac up here is representing a bursa, and that is cushioning this tendon here from additional stress from this bone. You'll see a bursa shown right here, and this tendon sheath, which is basically just an elongated bursa that wraps around a tendon. All of these contain the synovial membrane, which is going to secrete synovial fluid inside of these and allow for lubrication of these different joints. The last thing that I want to leave you with is a little story about my days when I was dissecting a real cadaver in the gross anatomy lab at the University of South Florida. Late one afternoon, me and one of my partners went into the lab so that we could finish up a dissection as we had a test coming up. I happened to be dissecting on the knee, and I'll also tell you that my dissecting skills at the time were not as sharp as I would like to admit. So as I was dissecting the knee, I accidentally popped the synovial cavity that was sitting in that joint, and the synovial fluid leaked all over the leg, and we weren't able to use it for the exam. There were two things that I learned from this encounter. The first of which is that when dissecting, always wear gloves. But the second thing that I learned was just how lubricative that synovial fluid is. Fortunately, I was wearing gloves when this happened, but I got that synovial fluid on my gloves, and it was probably the slipperiest fluid I have ever felt. So we will find that very lubricative fluid here in the synovial cavity, as well as in bursae and tendon sheaths, to allow joints to smoothly glide past each other and to reduce friction. That will conclude our presentation here on skin and membranes. I will see you all in our next lab recording when we'll start discussing one of the biggest topics of the semester, the skeletal system. Make sure that you get started on watching the skeletal system introductory video and then make your way into the axial skeleton. Don't forget that I am always here to help in the event that you need it, and I encourage you all to bring your questions to me. I'd be happy to help in any way that I can. So, I will see you all in the next lab presentation where we'll start discussing the skeletal system.